All right, so welcome everybody to episode 15 of the SFU Sports Analytics Virtual Seminar Series. Today we have Dr. Mike Jameson from Sport Logique, who's going to talk to us today about a computer vision themed talk on tracking players. What you see is what you get. Dr. Jameson holds a Bachelor of Applied Science and Masters of Applied Science degrees from the University of Waterloo and a PhD in Computer Science from the University of Toronto. He has over 15 years of industry experience in developing image search and real-time video analytics software for the security and surveillance industry. Currently, he leads Sport Logique's computer vision research team. At Sport Logique, his experience in real-time multi-target people and vehicle tracking is being leveraged to develop single and multi-camera tracking systems for a variety of sports, including player and ball tracking and game modeling. And for those of you who don't know Sport Logique, you should, because it's one of Canada's leading company in sports analytics. So it's based out of Montreal. It basically works with teams and broadcasters to help advance their goals in winning games or into engaging more viewers. They build advanced analytics software to track the location and actions of every player on the field, ice, or court using standard game footage. And then they use machine intelligence techniques to extract meaningful insights from the data collected, allowing teams and fans to understand and experience the game in ways that were previously unimaginable. So what he will specifically talk to us today about is that recently great strides have been made in the ability to visually track players in team sports such as soccer, hockey, and football. However, visual tracking scenarios are not all created equal. In some cases, the tracking system has full access to a collection of high-quality cameras offering complete, multiply redundant coverage in time and space. At the other extreme, the tracking system must infer what it can from low-quality broadcast of the game. In this presentation, Dr. Jameson will describe their methods for visual player tracking at Sport Logique, the various factors that affect track quality and coverage, and the implications for derived metrics. And so with that, I will hand it over to Dr. Jameson, who I'll ask just to share your screen, please. And we really look forward to your talk. Thanks for joining us. So Mike, you're on mute. I don't know if you're speaking at the current moment.
Yeah, sorry. My Zoom does things a little bit differently. Moves my mute controls around on me. So, okay. So, can everybody see this screen so far?
Yep, I can.
Right. Yeah, I prepared a lot of videos for this presentation. I'm not sure. We might be skipping through them a little bit faster, but we'll see how it goes. So the title is Tracking Players, What You See is What You Get. I just want to focus a lot on sort of different scenarios, particularly contrasting the multicam versus broadcast tracking scenario and how these two systems work. This is a shot from us at sort of the last CVPR that we physically attended. And sort of we have a fairly large research team, and some of the members aren't visible here, but I just want to remind everybody it's sort of a large team effort to sort of generate these results. So I'd just like to dive in with an example of something that's sort of possible using right now using a multi-camera system. So this is a set of 6 cameras set up in a NHL arena, and based on this based on the data coming from these cameras, we can generate 3D pose in real time for the game. It's not like pose that's accurate down to the centimeter, but it's generally pretty acceptable and gives you a pretty good overview of what's happening and what the players are doing in any given moment. There's some breakdowns in certain situations when players get scrunched together or high-speed collisions and things like this. But overall, my sense is with the 6 cameras, these 6 4K cameras looking at the game from 6 different viewpoints, we can generate a pretty detailed model of what's happening on the ice surface at any given moment. With the based on these 3D models, we can move the camera around, sort of see what's happening in different locations on the ice, and just see what players are doing. So in this case, but that's sort of contrasting to, we're overlaying this data with broadcast information, but we don't currently have the system in place to be able to sort of generate this sort of data. You can sort of see the 3D models breaking down there for that sort of thing. We don't have the system in place to generate this data from like a single viewpoint, which ends up being a much more challenging problem. So that's sort of like the most detailed data that we can generate in a sports setting right now is like not just identifying the players where they are at any given moment in time, but having a fair bit of information of like what their pose and joint angles are. So if I move along, talking about sort of overall camera coverage categories, we have, there's a lot of different ways you can track players in a sports setting. One of the more popular ways is have sensors on the players, have some sort of like RFID system. Some things use sort of a thermal system. Basically, any sort of category where we're putting equipment on the players and using hardware installed in the arena to track them. So this has sort of, every one of the options have different trade-offs. So you're going to get very accurate position data with this. It can have high infrastructure costs. You do get full tracking data because it sees the whole arena at any given moment in time. It's a lot harder to get body pose like we just saw from this sort of information unless you have enough sensors to like infer it from like every part of the body. And possibly you can get the vitals of the players. So data we're looking at just previously came from multiple fixed cameras. This stuff gives you really accurate position data, medium infrastructure cost. The cameras can see the full size of the play surface. You can also extract body pose, but we're not at the point where we can like read someone's heartbeat from a camera that's like 100 feet away or something right now, but maybe in the future. And then moving down to sort of broadcast footage. Traditionally, we put less accurate position information on this. I think it is still true, though I think the disadvantage of accuracy of position information is eroding. We're getting better and better at dealing with that. The infrastructure cost is zero. We can just, these games are already recorded, so we can just use the video. Partial tracking data because we don't see the entire surface all the time, though we like to think that we see the most important parts of the play in the broadcast video. We can derive body pose, but not right now 3D body pose, and no vitals in this case either. So Sport Logic is focused on the visual aspects, though sometimes we are using data from sensors or supplementing our information with data from sensors. All the stuff I'm showing you today is from the straight from the video. So, within these sort of broad categories, there's a lot of sort of details, a lot of distinct differences. The first 3 points in here are major differences between the multi-camera and broadcast scenario. So it's not just a difference in sort of the number of cameras we have looking at the scene. In the multi-camera scenario, those cameras are fixed, and versus a broadcast, the camera is moving, so that imposes another problem for us. It's a full-time versus part-time video availability, so we're really at the mercy of the video editor and when they choose to go to commercials and what they choose to cover. And if something important in the game happens when they're not sort of broadcasting it, then we have a little bit of problems. We just don't have that information available. So resolution and image quality, this varies a lot. Usually in our multi-camera systems, we like to have 4K cameras, and we sort of select for like high quality cameras. Depending on the broadcaster, like some broadcasts have like really good high resolution cameras and good sort of optical qualities on those cameras. As you move sort of down into lower level leagues, the camera quality tends to degrade, and it gets harder and harder to like say read player jersey numbers and so on and so forth. Of course, the environmental setting has a lot of effects. Whether it's raining or snowing, what the sunlight shadows are, how people design their uniforms can have a big effect on our ability to recognize different players depending on the setting. And even like little details like, how do you what sort of font do you use on your hockey jersey, say? There are some fonts that have actually been giving us trouble lately because they have some weird drop shadow format that like just makes it really hard to read depending on the video quality. And of course, camera work and editing. Some leagues, you can have two views within the same league, same set of camera settings, just depending on how they decide to produce the video. It can be a very broken up view of the game, or sort of a larger scale sort of tactical type view that gives you a whole lot of information. So it's not just sort of like, you know, two categories of multicam versus broadcast. Within the broadcast, there's a whole range of diversity in terms of like video quality and setting information. So this just gives you a little bit of an idea of what different types of inputs look like. In the one side, we have a broadcast view of a soccer game. In the middle, we have something sort of like a middle ground of a panoramic or tactical camera, something that's like looking at a very large chunk of the field without the interruptions from commercials and without like breaks to zoomed in views of players and so on and so forth, and without extra graphics on the screen and all those things. And on the right side, we have multi-camera input, where we actually have multiple views of the entire field, and we can integrate that data into sort of one integrated tracking system. So in general, the more data you have available to make decisions and identify players and identify where they are and what exactly is going on, the better. So the problem gets progressively easier as you add cameras and you add more viewpoints. I think I might move ahead a little bit faster. So one of the problems we have with, which I've brought up a little bit before, with the broadcast, sort of see context about what's happening on the field. So our first stage in our pipeline when we're looking at broadcast video is to like just get rid of the stuff that we don't think would be most useful to us, and focus on you know, cutting out the commercials, cutting what we see at a broad level. So how much do you see in a broadcast? We're looking at about, I think this is this is data for actually for a soccer match. So you know, we see usually about 30 minutes out of the total 45 in a half. So it's not really, shouldn't be histogram of user minutes in a period. It'd be a half for a soccer match. But yeah, so 2/3 or so of the video in a broadcast is generally considered useful. And the hope is that the sort of third that we're missing is generally not sort of like live gameplay and not sort of important aspects of the game. You can sort of see another view of that, 64% on average broadcast versus multi-camera in terms of number of frames, though it varies game to game depending on sort of the camera work that's applied. If we look at this is a view that superimposes the tracking data on the 2D surface from a multicam versus a broadcast tracking scenario. So you can see the open circles are the multicam data, and then they're filled in when the camera is able to see them. And then the solid smaller circles are the broadcast locations of the players and their identities. So you can see generally like it corresponds fairly well. There tends to be some errors in positioning, and there's always a potential for certain errors in labeling between the broadcast versus multicam. I'll go into the labeling problem a little bit more later on. But this sort of gives you an idea of like, sometimes the camera is visible, sometimes it's not, and we only sort of see certain aspects of the play. So, but the hope is that, you know, if the people doing the broadcast know their job, they're going to be like focusing on the most important aspects of the play. So this is just another sort of example of like what we might be looking at. In broadcast, we might sometimes only see a few players, and like a whole lot of other players are not visible, depending on the formation and camera view. So previously, I was sort of showing the breakdown in terms of time. In this case, I was wanted to look at breakdown in terms of coverage of the pitch. So in general, we find sort of in soccer, we're looking at like about 20% or so of the pitch which is not a whole lot on the broadcast view, but it tends to have like about 2/3 of the players visible, depending on the camera angles. And so if we look at like how we detect the visible players, this is a one of the core problems of doing tracking in both the multicam and broadcast setting is being able to find where the players and where objects like the ball are in the video. It's a long-standing problem. If we go back in the history of computer vision, way back in ancient days, like when I got my PhD, this would be sort of state-of-the-art stuff where we're trying to like identify objects in the image using handcrafted features and things like sort of a sport vector machine or decision forests as classifiers. And then you take this classifier and apply it to every patch and image at all sorts of different scales using a sliding window and basically say, is this the object I'm looking at? Yes or no, so on and so forth, many times. So this is not the type of thing that would scale up to being able to do the kind of stuff that we do these days. So luckily, the deep learning revolution came along, and we were able to do this a lot better with sort of end-to-end training on networks in terms of detections. So I won't dive into too much of the detail of those things, but it's made the system a lot better, and we've continually had improvements on these things. Player detection, I guess I would say, I'm very averse to calling problems solved because a lot of times they aren't, and a lot of people have said the tracking problem was solved like 15 years ago or something, but I guess we're pretty close to being solved. Definitely in no or low occlusion scenarios, it rarely makes a mistake in terms of detecting players. In high occlusion scenarios, when players are crammed together, you can start to see some errors, and that dealing with that sort of in the tracking system, particularly broadcast, can cause issues. And depending on, I'm going to go back a little bit, depending on the setting, like if we're looking at a football match or American football match, there are scenarios where it gets crowded enough that you can start to have trouble picking out the players, even with the latest approaches. So I should pause for a little bit about questions that have come up, or I can just keep going.
I've got nothing yet on the chat, Mike,
Oh.
so I think you can probably keep going.
All right. So in terms of number of detected players, broadcast or multicam, yeah, this is sort of showing, again, kind of like the breakdown across different games, like how many players we sort of see on average. Overall detection system, if they're visible, we're going to be able to see them in both cases. Then the question is, we can detect people on the screen, but what do we know? How do we know sort of like how that corresponds to the pitch coordinates? If we're dealing with like a sort of static multiple camera system, that's going to be very easy because it's you can even do this mapping manually. You can define a homography just matching the 4 points of the camera, and then any point you detect a player in the image on the left, you can map that to where they're going to be, or at least where their feet are going to be on the pitch surface. And if you apply that sort of however many times for however many cameras you have, you get a unified view. And then this mapping works for mapping from the plane of the image to the plane of the pitch surface. So it only works for sort of objects that are on the pitch surface. But you can see sort of like in all these different views, if you superimpose them, you'd have 6 views of each player, and they'd align at the location of their feet where they're touching the surface. And if you see a ball rolling along the surface, and it's not like one location and all the same, all 6 views, when the ball goes into the air, it separates into different locations depending on the viewing angle. So the problem looks a little bit more complicated in typical broadcast because the camera's not static. Though we have actually run into scenarios in lower level leagues where the cameraman seems to just take a nap or something like that in the middle of the game, and then the camera is static for a while, which is a little bit inconvenient. Generally, what we need to do is solve this correspondence problem between the screen and the ice surface for every frame of the video. And I'd say techniques for doing this have sort of improved over the years. In the few years I've been at SportLogic, I'd say we've gone from sort of approximately solving this problem to really close to a full solution. This video is a little bit old. It had a little bit of a problem on one of those things. I think that was an interpolation issue. But in general, it's especially on hockey arenas right now, we have really solid correspondence. So this again is a network that's asked to sort of solve this problem on sort of every frame with some sort of supervising logic about sort of smoothness and things like that. And in some cases, we actually have to correct some errors that the network might make, or sort of interpolate between certain scenarios where there's not enough markings to figure out what's actually going on. But sort of a recurring theme of the multicam versus broadcasting is because we have less data, you just have to be a bit smarter about how you use it. So you can see this is another example of the player location being applied. So we're mapping from the broadcast view onto the location on the pitch as the camera moves around. And then we sort of don't have data about the extreme zoom in locations. Cast tomography onto the view of the image, and on the right side, they're both sort of projected onto it's the sort of broadcast location on the image projected onto the templates. So you can see they generally align pretty well, but I think in this video there is a little bit of a systematic difference between the multicam data and the broadcast data. I think that derives a little bit from partly due to issues in our homography mapping from screen to pitch, but also I think in some cases this is actually not our multicam data that we're comparing here, and I think it's actually a little bit off. If you freeze on a few frames and stuff, you see sometimes there's actually the player is not actually where the multicam data says he is, but it's off in terms of order of 20-30 centimeters or so. So when we do this sort of across many different games, let's say in soccer, then we can see sort of level of disagreement between our broadcast and multicam in terms of position error. So right now the mode is at about sort of 0.3, 30 centimeters, 25, 30 centimeters, but there is a bit of a long tail in some of these errors. And some of those errors getting up to 1.5 meters, and so those tend to be sort of momentary instabilities in the homography, the mapping from the camera to the field. It's this system is sort of not perfect, and depending on sort of some of those factors I mentioned earlier about how well marked the field lines are, how visible, what the quality of the camera is, and so on, then we do have some games where the homography has more errors. Some games where it's just rock solid, and other cases where there's issues, particularly in lower level leagues. So I should have brought some video for this, but there are definitely situations where the field markings on a soccer pitch are not visible at all. So it's very hard to align it at any level of detail in that scenario. Another way of looking at this is comparing broadcast versus multicam player speeds. If we look on the left, this is a histogram of player speeds. Blue is broadcast, tan is multi-camera. But what the histogram on the left shows is sort of the difference between visible players' motion and sort of off-screen player motion. So what you tend to find is that players who are off-screen just don't move as fast because they're further away from the play, and they're just not running when they're not close to the play. Or at least in general, they're not. When we restrict the multicam data to the portions of player tracks that we believe should be observed by the camera, I think the alignment is actually very good. There's a slight disagreement about the shape of this transition from when people are in the walking, jogging phase to sort of low speed running phase. But overall, the alignment is extremely good between the broadcast and multicam speeds. if we look at moving on to sort of tying all these things together, when we do player tracking and multicam, again, as always, the story is because we have these multiple views, there's more information to support everything. So even when players are very close together and clustered, we can generate fairly accurate tracks of their position, because we can usually, if one camera, a player is occluded from another camera, they'll be at least somewhat separated. And if we can apply the same thing at hockey and soccer or American football. So that's sort of what that looks like in this scenario, playing out a little bit at higher speed. And it's just a question of associating these detections across multiple steps in time. In this case, this is what it translates into in a broadcast hockey scenario. It's sometimes hard to see. You can see sometimes players, we don't have a full identity on them, or not a fully confident identity. And sometimes those identities are not entirely stable. So we're looking at about, depending on the week you ask us, and sort of what developments we've made in the system, we're sort of looking at about 95% accuracy in many of these scenarios. So it depends again on the video quality. And these are nice legible numbers. I should have brought some examples of much less legible numbers. And they're basically impossible for a person looking at the video to read. When people have to annotate it sort of by hand, they're using a lot of sort of like hockey knowledge that we're sort of trying to incorporate. This is an example of tracking in a soccer broadcast. We actually have a new batch of results that came out this week, but I neglected to add them to my presentation. So hopefully next time. And just another view of that synchronized with the template representation. So I'll try to move along a little bit faster. Our main problem these days in the broadcast scenario is identifying players. So identifying teams is usually quite easy. In hockey, it's not terribly difficult. In soccer, it's a little bit more complex because in each game, teams are wearing different jerseys. There's no sort of like overall rule about appearance. But we are able to cluster these appearances of different team numbers, again, using neural network approaches and sort of assigning labels to the various teams. The harder part is assigning labels to various individual players. So one thing we look at is, can we read the jersey number on the players? And this is a video representing sort of network output for trying to read the jersey number. And so the long story short, some of these, sometimes you can read the number and sometimes you can't. Oftentimes the player is just not turned towards the camera, so you just can't read it. Then you're looking at using the associations that you formed, that it's like I can follow this player throughout the entire play of the camera, and if at any moment in time I can actually read their number, then I can sort of fill in who that should be, or make guesses about who that person should be. Another sort of powerful tool for like labeling players is their appearance. If we look at this is sort of output of a system, we call it visual re-ID system for identifying players. So if we have some tracks of players where we could see their number, and we have other tracks of players where we couldn't see their number, we can look at the players where we couldn't see their number and sort of refer back and say, do they look like anybody that we could see in the rest of the game who we do know their number? And this visual ID system will fill in a lot of the other information. There's still a sort of persistent few percent of uncertainty in who these players are. Another system we're looking at sort of partially implemented is relative location. So again, people in these team sports are playing certain positions. The formations adapt and so on. So it's not like sort of hard and fast rules, but there are sort of statistical structure in where people are, who they play, and the relationships between where they are going to be relative to the other players. So that is also very powerful information and helps us push it towards close to 100% identification. In this case, sort of where we are looking at right now, overall, this is actually somewhat a slightly more difficult test set. But in this test set, I believe we're hovering for the most part about 90 to 95% identification, though there's 2 games in this set where we're doing terrible identification rate. And both of those games are friends Newcastle. And that's just due to their jerseys. They are a nemesis in our object character player recognition problem because their jerseys are generally in broadcast unreadable. Even if you sort of like go through it frame by frame and try to like look at it very carefully, yeah, not legible. So other techniques need to be used to identify them. So a few other things we're looking at sort of beyond the tracking information is like generating higher level information about what's going on during a game. So this is the output of a sort of system trained on the broadcast data to identify, when is there a danger of a goal happening from one team or the other. So you can see an example output of that here, where they go towards one end, almost score, but don't quite score, and then it comes along here, and then we see a sort of high threat suddenly developing there based on the players, where people are on the ice. Another system is pass and shot detection. So identifying the moments in time when the player passes the ball, or receives the ball, or when they try to make a shot on goal. Just based on there's different versions of these systems. Some are based on the pure video data, and some are based on video plus tracking information. So I went through this a little bit faster than I intended because the time frame was a little bit shorter, but I'm not sure how we're doing for time right now. But any questions at this stage?
We're doing great for time. And sorry, is this the conclusion?
Yeah.
Okay.
Yeah.
So thanks very much for your talk. That's great. We've definitely got some questions. So what I'll do is I'll just open up the chat box here and get going on them. So Tim Wanuski asked for broadcast footage. So he's referring to slide 25. Was there major difficulties in dealing with variable sized arenas? If so, how did you solve them?
That is an excellent question. Well, so in the arenas, they're not so much of a problem. So NHL at least has standard size. In the lower level leagues, there's they also tend to be a consistent size, but there's a few ones that deviate. And the system that determines the mapping between the screen that finds the topography is flexible enough to like work with different size templates. So for some of those arenas, we basically have to create a different template, and that's a fairly in hockey, that's a reasonably manually intensive process because most of the rigs are sort of the same, except for the few and those ones that aren't the same are kind of like unique in their own way. Like they all have like sort of weird things about them, like they have more square corners or something, or a different distance between two of the lines. If we look at that in a soccer setting, there's a huge amount of variability because there are certain common sizes for the pitch, but there's still like within, FIFA specifies a very wide range of potential sizes, and we actually have to have a system in place that looks at the broadcast video and figures out what the size of the pitch surface is. But at least in sort of the soccer domain, the size of the pitch varies according to sort of fixed rules. So we can sort of, sort of adjust a couple of these parameters. The only parameters are sort of the width and length of the pitch. So we can adjust a couple of those parameters and sort of see what fits the broadcast data. And we can figure out where the location of the camera is and so on and so forth. Yeah, so that tends to work fairly well. We can also use sort of published pitch dimensions. And often those are reliable, but sometimes not. So.
All right. So yeah, that's a fantastic answer. So it's basically just like a pre-processing step, essentially.
Yeah.
Depending if it has to be live.
We do have a way of doing it live. In most of, like, so for a soccer game, so far for our product, we're using we don't have to give live results, but if we have to, we can figure that out. But that would mean that it's a little bit shaky for the first minute or so until the camera's seen enough of this field.
That makes sense. All right, thank you. That's it. Yeah.
Yes.
Great, thanks for that. Just check the chat form. Okay, so the one of the comments is I understand that some pitches are not flat, and how have you noticed that, and how do you deal with that?
We ignore that. I don't know. It was a big worry for me in the beginning. I think there is something. I mean, it's definitely true, and I guess we're getting it to the point where if we want to correct some of that, we would need to do that. I think we could model that. But so far right now, we just ignore it and we assume it's flat. A harder problem is that a lot of the cameras, so the default network is trained on, well, cameras vary a lot in terms of their distortion. And that is something that we have generally been ignoring and kind of treating them all as sort of like equally distorted. But in some scenarios, the distortion levels get quite extreme, and that is something we have to sort of correct for. But so far, we haven't worried about the non-flatness of the pitch.
Great, thanks. That question was from Jim Littles. Thanks for that. Josue, hopefully I'm pronouncing that right. Thanks for the talk. My question is, how do you fix or adjust errors of player team identification using methods outside of human manual fixing?
Well, yeah, basically our approach is to try to get the best automated results we possibly can. There is always the possibility of manually fixing them. There's some things that we're exploring in terms of having a person correct. If they see an error, having a person correct the error, and then having the system take into account that correction and sort of relabel all the players throughout the game based on sort of like a small set of corrections. But generally, right now we're doing fully automated output. And if a player, there's some players where we don't label if we're not confident in them, and there's some places where we label a player and we made a mistake, but usually those are fairly short-lived. Right now, we're just focusing on getting the best automated results we can.
Great, thanks. Hopefully that answers your question. Okay, so looks like it does. All right, Adam says, great presentation, Mike. Could you integrate this technology with physiological measures collected from devices that have real-time data? That is, could you apply a running heart rate number next to the athlete's number on the pitch?
Yeah, it'd be pretty. I mean, we have that. If we have that information, it's basically just a matter of software engineering to tie it together. And it'd be interesting to try and do that correspondence, like say, okay, yeah, we can really see this guy is moving now, and like, how does that correspond to like basically do that analysis at the data level kind of thing. But sure, like showing it sort of visually and like tying it to the players, I think is definitely possible.
Okay, great. So hopefully that answers your question, Adam. I've got a question or a few questions. So you talked about 3D pose estimation, so it showed some really exceptional video at the start on the hockey players. What applications would you use like that granularity of data for? What sort of metrics have you developed? Any metrics from that?
Well, the problems with getting the accuracy of the data is we don't really know. We don't have a good source of ground truth of like what the actual like pose joint angles and things like that for these players are. when we were doing sort of like validating this, we were kind of like looking at more for like things that were happening that didn't make sense, where the system fell apart, basically. But yeah, it's not. My sense right now is the stat is not accurate enough to do like some sort of like kinesiology or something like that, or I'm not sure. I mean, we're mostly looking at it as something kind of interesting to show the NHL and starting to get them some ideas. Another thing that comes out of this is that like when you know the 3D position of the player, especially when you see the 3D position of the stick, then you can more easily start to pull out like sort of details about like who got possession of that puck at that moment in time and so on. So there's, I guess there's a couple of different angles to it. So like one thing is sort of game analysis, having the 3D position of the stick and the players helps you disambiguate a few things in the game. And the other thing is just that like it potentially looks pretty cool. I mean, this is just a rendering that we have here. We improve this system. We could be doing it with like, sort of like models of the players and stuff. Though we'd have to fix things like when they're all smushed together. But potentially you could like, it could be a different way of viewing a game and sort of an entertainment type thing.
Have you considered injury diagnosis, like perhaps like, a hard hit and you see the head angle or something, like, concussions or
yeah, something? I mean, I think that sort of stuff is possible in the future. I just think we'd have to be a little bit more, we'd have to do a little bit more analysis that we're actually like getting some of these things out. Like, so one thing that happens here is that this system works very well in hockey, but we don't have as many pose constraints. When we applied this to soccer, it didn't work as well because in soccer, it's very important. Like someone plants their foot, that foot doesn't move, right? And in hockey, the players are gliding along. We don't really put the constraint on about like, there's a lot of additional constraints we want to have on the 3D pose to sort of like know that we're doing is actually sort of like physically correct. It doesn't sort of just look right. And so yeah, we just have to put more time into the system and improve some of those aspects, I think.
Great, thanks. So a related question, somewhat related, is you talked about the player appearance as a powerful tool for player identification. And so I was just curious, like in the models, like what are the actual attributes of the players that the machine learning algorithm is picking up? Or do you know, or is it like, is it basically their hair and their posture or anything?
We actually had an earlier version of this system that was learning too much about the posture and pose and sort of viewing angle of the player and too much sort of contingent information. In general, it's hard to know exactly what it's focused on. I don't think, I should ask the guy who trained the network whether he has some information about like what the weights of the network are focused on. But I honestly don't know. I mean, we constructed this stuff with the with an eye to sort of like providing the cleanest possible data to the network training and sort of and in terms of the loss function that we use to have that reflect sort of reflect how we would use that data in the production pipeline. But yeah, we let it decide what it wants to focus on. And, my sense is that it's focused on things like hair color and like, what the shoe color is and skin color and things like that. But there's not as much to focus on, honestly. Like in a usual visual reality scenario and surveillance, like everyone's wearing different clothes, people are different ages, different body shapes. Something like soccer, it's not, there's not as much difference between people, at least on the clothing level. And, they're all sort of like within the same age band and similar fitness levels and so on. So it's going to be it's even worse in hockey. Like, I mean, at least here you can see people's heads, right? In hockey, it's going to be like, it's a little tricky. There's not very much to go on.
Well, you should at least be able to distinguish the new Vegas helmets that are like chrome plated gold in color.
Yeah. So to that extent, yeah.
Okay, so that's interesting. I had another question that I was going to ask. Oh yeah, so like, what is the importance of color then? Like, imagine if you're trying to do this with black and white footage or grayscale. Like, how would that make it almost impossible in a lot of the applications?
Well, I don't think it'd be impossible. I mean, honestly, I think color. Well, so the most obvious place where we use color is in Team ID for soccer, where we're just trying to automatically identify like this is the home team, this is the away team, home goalkeeper, away goalkeeper, and so on. It's just because there's no sort of coherent, no consistent pattern, except that we expect them to have different colors. So we leverage that a lot on the soccer Team ID front. I think for the rest of it, I think most things would work pretty similarly. I mean, having a non-color image would make the detection problem slightly harder, but I mean, there's lots of, we don't miss many detections these days, and we could afford to miss some. I think, yeah, we could probably run it, most of the stuff on black and white. We just have to think about how we did Team ID in soccer a bit differently and retrain things.
Great, thanks. And so it sounds like, when you're dealing with machine learning, a lot of this is like black box. It sounds like, I mean, from the modeling itself, like, I mean, how much more understanding have you gained, or is, you're just, in most cases, you're just looking at predictive models, that are black box in nature. How does like understanding emerge, and how is understanding, like, you can think of maybe a Bayesian approach where you're integrating prior knowledge or contextual knowledge into these models. Like, how does that all work sort of on a technical front?
I guess there's sort of different levels of where this is happening. I mean, certainly as we, so, we don't basically like, we don't have a system where we sort of get video in one end and we have the tracking data out the other end, and it's just all like one giant network that we train. So we do have networks for specific tasks, and I think we get some insights into sort of what's going on as we sort of look at the errors that those networks generate in certain circumstances and where that's happening and why. But that's sort of like insight into those, into those problems that networks are trying to solve. And then there's questions about like how we put these things together, how we combine information from different networks, how we reason about like, the player identity problem, and how we sort of reason about sort of like when should we trust the output of one network versus another, that sort of thing. So there is some learning about that, like understanding the sort of tracking problem that happens on the researcher side. In terms of understanding the game, that's kind of like that's not my department, I guess. It's the people who like take the trading data or take the tracking data and like build game models and probabilistic inference about what's happening and sort of what plays are useful at what point in time and so on. I still don't like, I'm not as big a sport. There's definitely some people on the research team that are very much into the sports. I know a little bit about stuff. I know, from watching hockey on TV and things like that and playing it when I was younger. But yeah, I'm astoundingly ignorant about a lot of the rules and tactics and things like that applied.
Right on. Well, I guess that gives some hope. The quants some hope, right, for working in sport if they wanted to. So there's, sport knowledge is not necessarily a prerequisite, I think.
Yeah, but it can definitely help. I mean, when we're thinking about especially things like how we think about trying to encode like relative player position and thinking about that in terms of how we label players and how formations work, like someone who has watched a lot of soccer and understands sort of how the teams think about these things and sort of how that thinking is evolving, helps us design better systems for sure.
Right. Okay, last question for me is, so you've got your, the sports that you service and leagues and whatnot. Like, so suppose someone, like you've got the, very advanced technology that can be, reasonably generally applied, it sounds of it. So is there potential to license your products to be applied to non-traditional sports, like maybe high performance sports, Olympic sports that, like field-based sports like rugby or Aussie rules football, or, other sports where the problems are similar, but, like you guys just haven't applied your focus there yet?
Mm-hmm. Yeah, I don't know. I think every time we go to a new sport, we learn different things about our system and apply those to sort of core technologies. I mean, I think there's a possibility of providing access to like a lot of our core stuff. we're not really set up. I don't know. It's something that would have to be explored, I guess. I haven't really put a lot of thought into it. I think when you do go to a new sport, you're always learning something new, and about some constraint or something that's about the way the system is set up that's not optimal for this new sport, and we have to sort of rethink some of our components. Though as we add each additional sport, it's getting less painful at each step, so there's fewer surprises. Yeah, I guess there's a possibility of that sort of thing. One thing that comes out is like you do need data to be able to train these systems. So like we want to be able to train a good detector. We want to be able to train like being able to read the numbers, and we want to train like classifying all these various subsystems. We have training sets for the sports we operate in. And you could try using an off-the-shelf one, like apply a detector from one sport to another, and it might be okay. But I mean, for optimal performance, you'd probably want to have a training set specific to that sport and sort of like fine tune it at least. So that might be challenging. I think like a lot of times the most challenging thing is getting the data and getting good enough data to train all the models.
Right. Okay. Well, that's great to know that that's at least a possibility. And I think it would be interesting to look at because there's obviously lots of potential applications here. There's a few questions in the chat here. First is from Josh Gorham. Does each team get a generic data set, or do the deliverables depend on what the team asks for?
That is a good question. I think it does depend. We're definitely willing. Well, I guess it depends a little bit on the sport too. I've been thinking a lot about soccer lately, and I think we're at the stage where we're really listening to like what the teams want and trying to sort of tailor our product to that. But on the other hand, it doesn't really. So some teams just want sort of like physical metrics or something like that, and other teams are in a position to like take their raw tracking data and analyze that themselves in addition to the physical metrics that we calculate. So a lot of it depends on sort of level of sophistication of the team, I guess. And another thing that comes out is it doesn't cost us a lot to like provide, like if one team is interested in something and we code that up, then we can basically provide that at sort of zero marginal cost to other teams as well. So that is a factor that tends to drive us towards like providing the same options to everybody, even if they don't always use it. And I think on the hockey side is fairly consistent. Like there's a whole range of like stats and things like that. And different teams use different aspects of it. But I mean, I think it's the same. I guess it's not entirely true. I was going to say it's the same product available to everyone, but I think I have heard lately that for some of the new features, it's kind of like there's more and less expensive sort of packages of options available. So I guess it just depends a lot.
Okay, and so I mean, can you describe some of the variables that are provided in some of your product lines?
So soccer, it's like soccer, we provide anything from like our full tracking data plus all the physical. I guess it goes 3 categories, like tracking data, physical metrics, and contextual metrics. And the contextual metrics are still a little bit under development, I think. But so the tracking data has sort of like a sort of consistent format, we're going to say at this point in time, and then this player was moving at this speed and so on at this location on the pitch. Physical metrics kind of follow, at least right now, are sort of following what the data standard used in the EPL. So like the definitions that were used that were applied by the EPL data provider. Those are the multicam data provider that basically provides things like sort of like how long each player was running at each sort of like within a certain speed band. So they spent like this many seconds running, at the high speed running, this many seconds at low speed running, and so on and so forth. And contextual metrics is more about like around game events, like this pass happened, how much pressure was being applied at that point in time, and things like that. On the hockey side, there's a lot of hockey side is there's still a fair amount of like manual labeling going on in addition to sort of tracking and so on. So there's a lot of like a very detailed like game event stuff that's like either manually labeled or manually sort of verified. And that I don't have as much insight into sort of what's going on with that model, but I mean, there's all kinds of stats. It's like, you know, an online web page basically that you just kind of log into and can see sort of all the statistics and sort of like link into video of, you know, when a certain event happened or something like that. But there's a whole like, yeah, there's a whole world of on that side of the company that I pay attention to, but I'm not an expert on, so I can't really say.
Yeah, fair enough. But that was a great description. Thanks for that. Do you use commentary or like textual based data to supplement the video stuff?
I'm not aware that we are doing that right now. I know that sometimes when people are like correcting some events or something like that, they'll have the audio of the game available, so they might help them notice that something happened or notice that there was a certain player that did this or whatever. I don't think we look at text itself. I can't think of that happening, no. And there's some automated things about detecting events by sound as well in games.
Right on.
Like a referee whistle or something like that too.
Okay. So Peter asks, what have you heard from users as the data, like coaches, et cetera? Like, I guess, what kind of feedback have you gotten from the users?
My sense is that generally people like it a lot. It just depends on level. I know I've dealt more directly with teams in the soccer front, and it just depends on sort of level of how they think about it. A lot of times it's the raw tracking data is overwhelming, and some people are thinking more in terms of like, you know, which player runs the most during a game, or which player has a higher top speed and things like that. We're still sort of developing the soccer product. Well, we're developing all our products, but I mean, we're sort of still feeling out how things work with different soccer teams. So the hockey side, I'm a little bit more insulated from the direct feedback of the teams. I mean, I think all I hear is that people love the product and you know, they use it. I don't know if we have all the NHL teams using our product right now, or like there's one or two holdouts perhaps, but and we're also actually, some of our people who sort of grew up within Sportlogics as analysts have like moved on to be analysts for some of the NHL teams. So actually lost some talent to the NHL based on that. So, but I presume those people are evangelists for our product as well. So.
Undoubtedly. Peter, does that answer your question?
Yeah, absolutely. There's something you said there that I totally blanked on what I was going to follow up with a question. I just can't remember what it is now. Anyways, I was just thinking about losing talent, and just, you know, it kind of sets off emotions. That's like Professor Life. We lose talent all the time.
Yeah.
Great.
Yeah.
Oh, go ahead. Sorry, Mike.
Oh, sorry, I didn't. Yeah, it's just don't have anything particular to say. Sorry.
Okay. All right, right on. Well, I think it's a good time probably to end the recording here. So I'm just going to thank Mike very much for a very insightful and interesting talk, and for answering all our questions. So I really appreciate that. And if those of you want to stick around for a couple more minutes for some informal discussion, please do so. And we will see you in a couple of weeks. I believe it's Dr. Ian Schreier who is speaking. So we look forward to that. Take care, everyone.